Just a second. Try to connect the capture. Okay. Let's see the now try for OBS setting. Let's see. Wait just a second. Okay. Screen is just mirroring. Okay. And change the background color so it's more visible. So now I try to uh, clear the concepts of shift register, like how shifting is happened and what type of shifting are happened in digital electronics circuit. So here I take 3 bit shifting. So here is Q0, Q1 and Q2. So this is 3 bit shift register. So how these shift registers look like? So just uh, create a flip flop, next flip flop, and another flip flop, and how it's input and output. So here is the input, here is the output, here is the input, here is the output, here is the input, here is the this is D flip flop, D flip flop. So everyone is everything is D flip flop. So this is my Q not, sorry, this is not Q not, the output Q not, this is D not. Let's assume this is D not. Let's this is Q1, this is D1, this is Q2, and this is D2. So it's a if I make a serial in, like serial in and serial out type of uh, shift register. So what happened? This is like if we take 3 bit data like 0, 1, 0. So first 0 when the clock, like in this D flip flop, the clock like that. So so this is the clock. So when we try to 0 to give D2, so if the clock is high in the like it's a positive edge clock, when comes positive clock at D flip flop on uh, Q D2, that times what happened? This 0, this 0 will insert to D2 and like this insert on D2 and this flip flops Q2 data equal to store 0. So this is the first flip flop, D flip flop. When clock comes, this Q holds 0 value. So 0, 0 value store at Q2, and here is another D flip flop, and it's if we connect it directly, just like this way, we just connected directly. So in next clock cycle, in next clock, what happened? This one, this one store to this flip flop. So in this next cycle, this one goes to this one goes to here, just because uh, we trigger the clock and just this D flip flop will uh, will input data 1 that will go to output Q2. And what is the Q1 now? This is the Q1. So it's connected previously with this, the input of Q output of the Q2 connected with the input of the this flip flop. So now D1 was 1 previously. Now this one transferred to Q1. So now Q1 is equal to 1. So what's the left? That only one bit left, that is 0. So 0 and rest of the bits are stored at here store 1, here flip flops flip flop 2 store 1, flip flop 1 store 0, and another flip flop we had, so that this was connected in flip flop 0 number. So here's now we see the output, and here previously it was connected and the clock in every flip flops, and now 0 this data goes. So when the clock we apply, like it's a positive edge trigger clock, when we apply, then what happened? Just a second. So then what happened? That 0 goes to here and 1 goes to here and this 0 goes to here. So that's the way, like serial in serial out type of uh, shifting is happened. This going to 0, this going to 1, and this going to 0. So that's the way 0 1 0 store. Next is serial in but parallel out type of uh, shift register. And by the way, in this previous circuit, how many clock cycle required for store the data? So that is 3. So basically it's uh, 3 bit, so 3 clock cycle. If it was n bit, then it's n clock cycle required. And what the cycle required for retrieve the data? So it's already like these 3 block. It's already there was 0, here 1 and 0. So if we connect the output from here, already we get 0. So next we need to just put one clock cycle for retrieve this data 1, and and that time this data going to this flip flop input, and this and another clock required for this retrieve the data. So total n minus 1 clock required to retrieve the data in in serial out type of shift register. So total clock cycle required for storing and retrieve the data. So that is n plus of n minus 1. That is 2n minus 1. Now uh, serial in parallel out. So again we take the same bit number 0 1 0 and we one flip flop, second flip flop and third flip flop. So here the clock cycle and here the input of this this. But how we take the output? Output will take like this from here. So the data 0 1 0 first in first clock cycle, that is 0 enter, and then 0 enter to the store 0. So 0 store, next clock cycle 0 will go to here 0, and this 1 now comes to the this part, so 1, and so that is two cycle. In two cycle 0 will be here and 1 will be here, And again another clock cycle required for 0 to be here, and one previously was in like in here, so one should be now in here and 0 should be now here. So three clock cycle required for storing the data, storing data. But when comes to the like retrieve the data, tracing the data from here, like Q0, Q1, Q2. So zero cycle required because already data will present here. You can see that this zero is already present and this one already present at this position and this zero already present. So total clock for uh, storing and retrieve the data, that is n. N for n flip flop, like you want to store n bit, then n flip flop required, and for n flip flop n clock cycle required, clock cycle required. So that is serial in, parallel out. Like you put the data, store the data serial wise, like here, then goes to here, then goes to here, then goes to here, like that. But when it comes to the retrieve the data, then you just take the output parallelly, one here, and one here, and total number of clock cycle, that is n. I already told. Now next is um, parallel in, serial out. So what is parallel in, serial out? So again we take three flip flop. So parallel in, that is like that, like that, like that. So you put the data parallelly, like your our bit was 0 1 0. So you put 0 here, 1 here, and 0 here. So only one clock cycle required. Only one clock cycle required to store the data. From here it is 0, so 0 will be stored. Here it will be 1, so now 1, and D0 at Q1, the sorry 0 will be stored. But this is parallel in, so data will be parallelly in. So one clock cycle required for parallel in, one clock. Here clock we give clock. Now that serial in, serial out. So how we take the data serial out wise. So now it's connected this, like that, this, like that. So initially it was blank. Now it will be stored 0, 1, and 0. So already if we take the output from here, so 0 we already got. So if we want to access the 0 data, like q this flip flop 0 data, then we don't require any extra clock cycle. So it's don't require extra clock cycle, so we can retrieve the data. But when it comes to the this flip flop, this flip flop store one data, so these take one cycle, one cycle. So these take one cycle, so this data will go to here, so it's one. And this data at the same time, clock, like clock is everything is going at the same time, so this 0 data will come here. So in flip flop uh 2, if we say flip flop 0, flip flop 1, flip flop 2, so this is flip flop 2, this 0 data store at the flip flop 1, and it will take another clock cycle to go this way. So this. So what's the total clock cycle required? Total clock cycle required for storing the data. For storing the data, it will be one, like parallel. Everything is parallel, so parallelly in, parallelly in, parallelly in. So parallelly in. So 1. Storing for storing purpose, it's 1. But when it comes to the retrieve or access the data, it will take 1 is already there, like 0 data is already there, so it's no, it don't take any time. But these these took 1 clock cycle and these took 2 clock cycle, so total 2. So total data will be like total clock cycle will be required for storing 1, even n bit also. And when it comes to the retrieve or access the data, that will take around n minus 1 clock cycle. So total will be total, if we access from storing to access the data, it will take n clock cycle. Now is parallel in, parallel out. So again, we take 3 flip-flop. So now parallel in, parallel out, parallel in, parallel out, this like this. Here Q naught, sorry, it's not Q naught, it's D naught, D1 and D2. And here Q2, Q1, Q naught. So the data was previously we assume 0, 1, 0. So if the clock cycle at the same time we give clock to every flip flop, so that time what happened? This 0 will go to here, so store, and this one, sorry, this one that goes to here, and this 0 goes to here. So we need one cycle to store the data from, need one cycle, store the data, one cycle to store the data. But when comes to the retrieve the data or access the data, it takes um, zero cycle, zero cycle, just because data is already present. So if we try to input from this, we'll get the data is 0, 0 here, 1 here, and 0. So cycle 0. So parallel in, parallel out, only 1 clock cycle required, even it's n bit. I hope this concept is clear now. And if I got any mistake, then let me know in the comment sections. And yeah, that's all.